Hello, everyone, and welcome back to the Unleashing DePIN Podcast. My name is Tyler. I am your host, and I'm excited for this next conversation that we get to have with a project that is doing really cool things in the DePIN space. Before we jump in, I did want to make one quick announcement. For those who have maybe seen on our social channels, we did just announce a public good tool for the space called DePIN Pulse, which helps individuals find earning opportunities within DePIN. And so if you want to go check that out, it does help support the channel, helps keeps all these awesome conversations going on the podcast front. So with that, I wanted to say hello and welcome to Jesse from Nosana. Jesse, welcome to the podcast.
Thank you. Thank you for having me, Tyler.
Absolutely. Well, I'm excited we get a chance to have this conversation that's sort of been in the making for a little bit here. But why don't, before we jump into everything, if we can level set with the folks listening, can you tell everybody a little bit about who you are, kind of how long you've been in the space, how you got into DePIN specifically, and then we'll kick it off from there.
Of course. I've been in the Web3 or cryptocurrency space for quite a bit. Like back in 2011, 12, I was very interested in Bitcoin, like the technology behind it mainly, and also Ethereum and the blockchains that came afterwards. But I obviously have a technical background. I studied artificial intelligence in Amsterdam at university. I did my master thesis at the Deep Learning Lab. So I was really interested in both these worlds of artificial intelligence, which back then it was a completely different scene than it was now. Like this was when I started university, we were just getting started with the first neural networks that could detect simple images. So they would do cats and dogs. They could take tell them apart, but that was sort of the level that they were at. So it was an amazing time then, seeing that progression in creating these generative networks. So after university, I really wanted to do something in the decentralized Web3 space related to artificial intelligence, as I was very passionate about these topics. I've always been very into free software, open software, and blockchain just fits really well into that world as well. So what I did was I co-founded a Web3 startup, a decentralized AI company called Effect Network. Back then, it was 8 years ago. And we were working a lot on creating data sets for AI in decentralized crowdsourcing way. So people would get paid micropayments on the blockchain for doing annotations and teaching AI new things. Which was a very cool project. I managed to work also in a lot of ecosystems. So I did a lot of development on, for example, EOS, Ethereum, Binance Smart Chain, and lately a lot on Solana. So I've been really active in the Web3 space professionally as a developer, but also as an entrepreneur and just active as a community member in these open source ecosystems, which I'm very passionate about. So that's just a bit of background on where I came from. When it comes to the DePIN space, I guess that's kind of a newer term. So back then it wasn't really around. But one of the things that kind of drove me in that direction was during all my years working on decentralized ecosystems like DAOs and staking protocols, and we're creating all these beautiful applications that are permissionless. Anyone can use it. There is not a single entity in charge. But we're still hosting all of this on centralized hardware providers. If you look at the numbers, I think 60% of the whole internet, that includes Web3 blockchain nodes being run, including the front ends that are used for different dApps out there. They're all hosted by 3 companies, right? These 3 big, huge companies, they still control all of it, which just is very sort of weird and painful. So that realization drove me more and more towards, we need to get a decentralized energy, a decentralized force on the hardware level, which is the physical infrastructure. We're running all our applications, the technology foundation basically that we use, that needs to be decentralized as well. For me, that's what DePIN is really about. And I founded Nosana with my co-founder around 2.5 years ago as basically, to solve that issue.
Yeah, no, it's amazing. It is kind of ironic in a sense that you've got all these sort of distributed systems, applications and whatnot, but the underlying kind of server hosting side of that is, like you said, it's ran by 3 companies, and it's a little bit of a disconnect there. And so leveraging this DePIN term that you said is new I think it's a really great application for trying to sort of address that problem. So you've been in the space for a while, sort of in the different areas where it's relevant, right? On the Web3 side and AI. What was the catalyst, if you will, or sort of what was the initial problem set that you're like, hey, this is really an issue that was sort of a driver for starting Nosana? Can you talk a bit about kind of that catalyst for everybody?
So when Nosana started out, that was 2.5 years ago. It was still pre the AI boom, like when ChatGPT got released and shortly after other softwares got released. So we were on this journey, basically this journey of trying to make the infrastructure decentralized for the internet. Kind of an ambitious big journey. But once ChatGPT came out, we could see that there was this massive demand being generated for running artificial intelligence specifically. So if you look at like the internet websites and web servers, they run on servers, right? Like these big server racks. And they could potentially run on their home devices as well if you want to build a decentralized version of that. But if you look specifically at artificial intelligence, this requires GPUs to be run. GPUs are these devices, specific chips. They're being used a lot by gamers. Anyone that games knows NVIDIA, of course, and the gaming chips that they make. So once we saw that happen, like we could easily project the growth of artificial intelligence after this really pivotal moment where LLMs became mainstream. And shortly after ChatGPT got released, there's been this booming ecosystem. Maybe less people know about it, but there's this open source, massive ecosystem of people building open source models. It started with Facebook. They released Llama, which is an open source, open weights version of ChatGPT, basically. And out of that, like tons and tons of different models branched. And it gave us as an open source community a really powerful tool set to run and build our own AI. So what we immediately identified was, first of all, there are not enough GPUs on the world, like in the cloud, that's currently available for rent to power the demand of artificial intelligence. So the open source community is creating all these beautiful new use cases and creating these new AIs they can run on their hardware, but there is not enough hardware on demand available. So it will only be the bigger companies that can afford the GPUs right now to run this. I think that moment was like the catalyst. As we could see this happening, we already created a network that was really good at running hardware in a decentralized way. It was the first version of Nosana. But Nosana, as it is today, really grew out of that moment when the demand for AI started increasing, and we built our network in such a way that like anyone that is building AI, like any AI developer, small company, big company, we allow them to access the GPU hardware they need to run artificial intelligence. So yeah, basically the catalyst was the AI boom, open source AI models becoming popular and creating this massive strain on GPU hardware that we're trying to solve. And we're getting pretty close right now.
Right. That's amazing. How do you solve the problem of, okay, there's clearly not enough compute resources? How is Nosana really tackling the problem of getting more and more nodes, if you want to call them that, or sort of compute resources into the network? What does that look like from a very tactical, I'm someone that has excess, maybe I've got a computer that's not being utilized or other hardware resources. How do they join the network and sort of become part of that process?
Yeah, that's a good question, right? Because we identified that there is this shortage of hardware. I remember like 10 years ago, I was doing this research in AI, and back then in the research lab, we were all, even then, struggling to get our hands onto the GPUs we needed to build models. It was really like you were just waiting all day, frustrated until you got like an hour of GPU time so you could run your experiments on those devices. And since then, artificial intelligence has become, in the last 10 years, 1,000,000 times more powerful, like 1,000,000 times. That's like
wow.
That you cannot even comprehend how big that growth is in capacity of these models, while the hardware has only increased a little bit. So there's just this strain on hardware. Not only are there just way more models around and they're way bigger, the hardware production cannot keep up with it. But what we realized and what was identified in the communities after Llama got released is that consumer hardware is very good at running AI. It's not so good at training AI, which is a different thing, and it's not so good at a whole bunch of things in AI, but when it comes to running LLMs, so like running Llama, consumer hardware is even more efficient than the cloud hardware. So there's basically these two pools of hardware, right? One of them is in data centers around, like owned by these big companies, and there's a lot of GPUs in them, but they're specifically built for these data centers. And then there were the gamer GPUs, and just I think by luck almost, they are extremely good at running these LLMs, like really, really good. So taking that into account, that the logical step is, all right, let's bundle these gamer GPUs that are often not being used fully, right? Like if you buy a gaming rig and you buy a cool game, you're gaming maybe 4 hours a day for a month, and then your device is catching dust for a year, it's not doing much, and it costs a lot of money. So there's a lot of potential in all these systems that are sitting in people their homes. So that's where we get the resources from. So by creating a network where all these gamers can connect their hardware, and using nice user interfaces and the right way to bundle them together, we can have companies use that hardware to run their AI. And it's estimated there are around 300 million gamer GPUs around the world that are capable of running AI efficiently. And that's a really big number. That's more GPUs than there are available in all the clouds combined. So 300 million gaming GPUs is like, it's more than enough to fuel the current demand for AI. And if we manage to extract that power and make it available in a marketplace, which is what Nosana is doing, then we are definitely able to bridge that gap.
Yeah, that's amazing. So is your ideal sort of target demographic really folks who have these gaming rigs that were set up that they're maybe using for a fraction of the time for the actual gaming side, and then they're able to provide their compute resources in the network as sort of the other 80-90% of it, and they're able to earn on top? Is that sort of your target demo, if you will?
Yeah, definitely. Like, we're mainly gamers are like the primary audience, I would say, and there's a lot of variety in these chips. So we're shifting a little bit in like where the most demand is from the AI side. That's also where we are focusing on for our supply side for the gamer side. But gamer side, there's a lot of them out there, and some of the rigs are amazing for AI. We also connect some like mining rigs. If you look at some mining rigs that were used to mine Ethereum, for example, they're not profitable anymore in a lot of cases. So they can be used as well for running some AI models. They often have like a lot of GPUs in one rig, which allows for some special setups and some more efficient ways to run things. And there's also some like machine learning nerds and people that buy these rigs at home, and they have like really good setups, but they're also using only a fraction of that themselves, which like that's also there's quite some like really good deep learning rigs that are sitting in people's homes also available on our network. So we have quite a big variety of things, but the majority of our supply side community is gamers, I think.
Yeah, that's great. From a sort of a tactical level, when you've got varying levels of compute resources that are joining the network, how is sort of the Nosana protocol really leveraging the different strengths or maybe the different capabilities that they have to create kind of a uniform experience for actually powering these LLMs? Can we kind of geek out for a sec and dive into how that works on a little bit more of a technical level?
Yeah, of course. So we're in the end, we're creating some kind of orchestration layer where we have all these AI workloads. So you might have your Llama 3 70 billion parameter model that you want to run on a hardware setup, and we have to match that on the supply side. So we have to match that to the right devices in our network. That's kind of the challenge that we're tackling, and we are still quite early phase when it comes to that. Like we're rolling out our first version of the product that basically we have pools of GPUs that have the capacity to run certain models, and clients can basically pick a pool of GPUs. So I have this workload, I'm picking this pool of GPUs, this is where I'm going to run my workloads. And you get basically a scalable group of GPUs to run different things. From there on, we're looking to basically make that matching mechanism more advanced. A lot of it happens on-chain, but for example, we're looking right now in matching on way more aspects, because even CPUs are really are a big factor in this, and how much VRAM and normal RAM do you have, the disk space, your bandwidth, all these factors. We're kind of right now doing a lot of benchmarking and figuring out which are important for which models, and how can we match you to like exactly the right node for your use case. Because nowadays with LLMs, you have like you can pretty accurately make weigh your importance on, for example, performance and price. If you're okay with getting a bit less words per second, like tokens per second, which is basically how quickly your LLM talks to you, if you're willing to sacrifice some speed there, you can get like a very, very cost efficient setup. which for a lot of people is attractive.
Yeah.
If you want to get paid, you can get like way faster than even ChatGPT is going by getting a really specialized setup of gamer hardware to run like some of these models as well. So there's a lot you can tune, way more you can tune than, because there's so many devices and things out there. And then there is a whole other part of the matching we're also still developing, which is basically the geographical location of your nodes. So getting nodes that are close to your workloads is also a really big benefit that we're going to exploit and make sure our network is even more efficient than a lot of clouds by getting hardware close to the demand. But we're like I said, we're still in an early phase, so we're just rolling out our first customer workloads this month actually on the network, and we're taking it step by step. But it's quite an ambitious project in that sense.
Oh, without question. Well, and it is solving a real big pain point and problem. It's kind of ironic. You've been in the space for a long time, so I'm sure you'll very much empathize with this. But as you're quite aware, over the last, 5 or 6 years, is sort of these GPU resources have been fairly scarce due to supply chain things and whatnot. There was always this contention between, Web3 really sucking up a lot of those resources for providing the actual, taking what was otherwise used by gamers. And they were like, hey, everybody's buying up these resources. We can't buy our gaming rigs. And now the tables are sort of turned where you're able to leverage those GPUs that are being provided by gamers or sort of in their rig back to this crypto thing. It's amazing how that kind of comes full circle in a sense. So it's really clear who you're targeting on the supply side. On the demand side, what does that look like as sort of your ideal target customer from people that are, needing to run these LLMs? Can you talk through that a little bit about, who's actually leveraging the network today, and as you're starting to roll out those new versions of your product, what that's going to evolve into?
So today, things look like our ideal customer today is definitely different than it will look in 6 months from now, 12 months from now, as we're like starting up as a network. And the reality today is that Nosana is a very early network. It's very experimental. Like you're running literally your workloads on gaming PCs in people their homes around the world. And like you're streaming that data back and forth. So there's a lot to be, and like we're running the first workloads right now, the first production workloads. So because of this experimental nature, we're not really chasing any like mission critical workloads. We're not chasing any of the bigger companies that have really big privacy concerns and on the data side, but also on the model side, there's a lot of privacy concerns for these clients. So what we're working with are a lot of startups that are just, getting their products into the market, and they're looking for access to GPUs, because that's one part that like just we have such a variety that we can say, look, we have 1,000 GPUs, they're online right now, and we can give them access to the right collection of GPUs. We're not very strained on the supply side even at the moment. So we can really accommodate a lot of these new companies coming up with cool ideas. We're also working with a bunch of universities to run workloads on our system. So like all of these clients that have like, they have a lot of benefit getting access to diverse and well-priced GPUs, but they don't have mission critical software that needs to be online 24/7. That's the demographic we're going for now. But of course, the whole purpose of, we call this space test grid. It's where we're having tests like, it's production workload. Like these clients are actually using this for a real use case on the real network. But we're still calling it a test grid in the sense that, things might go down. We might, like, if the Solana blockchain, for example, has any congestion issues, our network is down as well. So we're also connected there. So there is some instabilities around. But we're really using all these learnings right now to make the system more robust and to get to the, pricing models and uptime guarantees that make sense on an industry level, so we can serve the big clients as well as soon as we can.
Yeah, that's amazing. So with your test grid now, can you talk about some of the relevant growth metrics that are associated with that? You said 1,000 nodes are on the network. How has that changed over the last 6 months, and sort of where do you envision that going in maybe the rest of the year for 2024, for example?
So we started, I think, the first phase of test grid mid-December, and we just had a bunch of nodes, maybe 10 or something, running like connecting and running some workloads. And that gradually grew to, I think, 100 nodes, which we had running for a few months. This 100 nodes was basically the first phase where we were testing a lot of elements of the network, including like upgrades, network upgrades, latencies, node performance. So we've been running like 100 nodes for a while. Then, like as of last month, we've upped the limit again to 1,000 nodes, and I think we're growing very quickly now to that capacity again. So we're going to do the same thing at 1,000 nodes and run the network for a few months, gathering all the metrics. I think we're now at 500, 600, maybe 700, around that number of live active nodes that are running workloads like continuously almost. So like they're waiting online, and like we can really see them performing well. So yeah, that's where we're at from the supply side. Of course, we're a marketplace, so any marketplace needs to be bootstrapped. So that's also why we decided to start with the supply. So we have this steady, sort of predictable and accountable group of nodes running workloads. But as of this month, we've been onboarding the first clients as well. So we have, I think today we announced a third partner that's going to run workloads on our test grid this month. And they're quite diverse. They're like startup size, maybe a bit bigger companies that want to experiment with LLMs in their environment. So I think one of our clients is Aurora, a game on a Web3 game that wants to embed AI and LLMs in their NPCs and agents. So we're going to help them out and provide the infrastructure to run Llama 3 in different configurations. There's a bunch more, but we have quite cool use cases already going on.
Yeah. What are some of those use cases that are particularly interesting or exciting to you? Can you talk about some of those a little bit?
Yeah. So gaming is pretty cool, I think, because gaming and AI just really go well together. So Aurora is a good example. Slightly related to gaming, but we're working with Matrix One. They create a product called Avatar One, which are virtual girlfriends. So you can design your own perfect girlfriend, and there's like an LLM behind it that you can interact with, like on a chat-based level. So they obviously need a lot of different types of LLMs to power this. I think a very cool use case is this can, it scales. Each girlfriend gets their own LLM, and you have like they can run this on our hardware. Another very interesting, I think, product that you see getting more and more popular is like Hugging Face type marketplaces. I don't know if you're familiar with Hugging Face, but it's a marketplace for AI models. It's growing very quickly. So like most of the open source artificial intelligence models are listed on Hugging Face. It's basically like an index. It's been growing incredibly quickly since Llama came out. There's also a lot of data sets on there, but you get this one-click way to deploy your. So it is this, like basically a database of all the models out there. They have ratings, descriptions, and you can deploy them with one click on a cloud. So there is a decentralized like alternative to that's coming out, Alpha Neural it's called, and we're gonna work with them on being the compute provider behind their models. We would love to be the compute provider behind Hugging Face, but they're just like so big at the moment that it's a very hard wait for decentralized projects to get in touch there. But all these products that are basically creating decentralized AI marketplaces and needing compute power, I think is just very useful, as the decentralized aspect is powerful. And I think having decentralized compute with decentralized AI marketplaces is just a beautiful marriage where we can have like a full circle decentralized way of using and interacting with AI, which is the big goal, I would say.
Absolutely. So with your test grid, you said you started out with 100 nodes on the network, scaling that up to 1,000. Are there any other kind of core differences between where you started back in December and where you're at now with respect to the protocol on the network itself over and above the kind of compute capacity?
Yeah, definitely. We're taking a phased approach here. So we started out with 100 nodes and then growing that out and making sure that the node side of our platform is very stable and grows well. And then that we call this test grid phase 1. Is this basically the first thing where all the necessary elements are in place, tokenomics are sort of working, and everything, it operates. In phase 2, that's where we currently are. We're onboarding clients. So we're working with a big diversity of client requests and things they need from a GPU side. So we're working closely with them and creating the CLI tools and the SDKs and the libraries required to interface their applications with our grid. That's the phase we're currently going through, and we're seeing some nice results, but we're like in the middle of it. But at the end of this, we're going to have all these interfaces for people to easily tap into Nosana's GPU compute. So if you're programming your AI application and you're like, okay, I need like a 34090s right now to do some fine tuning and to do inference, it should just be as simple as import Nosana and you're running. You can run on our GPUs instead of wherever you would do that normally. And then after this, we're going to the third phase of our still test grid, but it will be more around getting enterprise ready, sort of like we want to make sure that the network is secure enough. We want to make sure we have all the right measures in place to punish and kick out malperforming nodes. It's a really important aspect. Right now, we're so small that we can manage it with some statistics and some ways we can control the network still. But in the third phase, we want to put the elements in place to make this sort of a automatic process. So nodes will get slashed. They will lose tokens if they, for example, cheat, or that they may be running a different hardware setup than that they're pretending to be doing to earn more tokens. There's a lot that can go on there. So the third phase is around making the network robust and more permissionless and decentralized. And then after that, we're sort of ready for a mainnet release where anyone can join. And just like to add on that, for Nosana, one of our main goals, and I think what makes us sort of unique as well, is that we want to make this network completely open, permissionless, and decentralized. So all the code that's currently running is open source. Anyone can see it, review it, compile it, make changes to it. And including the smart contract stack is all open source. And we really want to make this a network where the market effect is in control. So we're doing as much as we can on chain and not be the man. Like Nosana doesn't want to become the company in the middle of this to control things. We want to make sure that it operates on itself and governed by communities in the end. So that's where we're going.
Yeah. You talked about sort of the ensuring that there's no gaming on the network and sort of there's, nodes that are taking advantage of it. Can you talk about how the economic model works today as you're in sort of the test grid, and then what that'll look like when it becomes more decentralized and more permissionless and whatnot? Is it there's sort of you join the network and there's a insurance of token rewards, but as that becomes more utilized on the demand side, will that translate more to like a usage-based model? How does sort of the economics of the protocol work today, and what will that be in the future?
Yeah, great question. So we're going to make changes to this model in the third phase of test grid, as we're already seeing ways to improve it. But right now, how it works is if you have a workload and you want to get access to a GPU, you can look at all the different types of GPUs that are available. That happens on a software level, obviously, but then you pick the GPU that matches your workload and you can reserve it for an X amount of time. And you would have to pay that in advance. So if you say, okay, I want this GPU for 2 hours, you would pay 2 hours in NOS tokens upfront. That's locked in the smart contract. And the node will start running your job. As soon as it's finished, or when you're done with it, you can signal to the node, I'm done with the job. You would get refunded the part that you didn't use of that 2 hours. And that's sort of how it works. So you're paying on basically a per second basis, but you're paying upfront to ensure that the money is there, basically. And on the node level, a node has to stake tokens. This is not, it's already technically there, but we don't require this at the moment. But as soon as we're a bit further down this test grid, nodes have to stake quite a large amount of tokens in order to be able to qualify for work. And if our system detects that a node is misbehaving, maybe it's not putting the right results out, maybe it's running things on slower GPUs or anything like that, they risk getting slashed, which means they lose part of their stake, and it's going to be used to compensate the clients that got the bad data from it. And this part will get activated and refined when we get into the third phase of test grid, so a bit later down the road. But it's a very important part of the network as well. And the main improvements that we want to make right now is to get a more stable rate for paying for GPUs. There is a lot of other DePIN networks out there that have quite cool models, I think. When it comes to this, like a burner mint equilibrium is quite popular in some networks, or different ways to get stable coins or stable payment rates. For example, GPU seconds or something as a payment rate could be an interesting one. So we're working on different ways to tackle this, to find the best solution that fits our network. But there are some improvements on the roadmap that are going to tackle that.
Yeah. One of the things that I love both about just DePIN in general, and then specifically, what you're able to bring to both those on the supply and the demand side, is obviously solving things like latency and solving the fact that it's not ran, the network isn't ran by three big node operators that, we sort of all know, the big compute players, but you're also able to drive a lot of costs down for the network. So people that are looking to leverage these GPUs are able to do that more cost effectively. Can you talk about how DePIN is sort of enabling that from the demand side benefits to actually create a service and a product that's not only distributed, that's not only maybe more performant, but also more cost effective as well? Can you talk through that value prop a little bit?
This is one of the powers of DePIN, right? That we can really optimize the efficiency of networks like this, and also the cost efficiency. So in our case, if you look at all the GPUs around the world that are available, being able to access any of them at any time and being able to schedule workloads on geographical good locations, and also like when GPUs aren't being used, it's like an incredible way to push down the costs of running things. Even if you look at electricity costs that are really fluctuating around the world and are so different geographically, there is a lot of ways that you can cost optimize around different regions and different and electricity costs are sort of the driving factor, I think, on the long run when it comes to powering GPUs and AI. So there's all these cool things that I think DePIN enables. And this comes from the fact that you can reach any of these GPUs and do like micropayments to any of them, and the indexing of all these devices and how easy it is to join the network. I think it's the only way to do it is with DePIN technology, and this is how we cost optimize. So already right now, we're a lot more cost efficient than data centers. I think a lot of this comes from the fact that we don't have to purchase hardware. Like the hardware is already bought by people, so that initial purchasing, the initial purchase you have to do for that hardware doesn't have to be done anymore by these people. Like that's sort of psychologically you already have that device sitting there, so you don't have to count that in fully. And then the upkeep of a big data center is quite complicated and expensive, while people have already infrastructure at their homes to facilitate the necessary like bandwidth and electricity supply for their GPU. So it's more sustainable and more environment friendly and a lot more cost efficient if done right, which DePIN enables here.
Yeah, absolutely. And one of the things that you touched on really briefly that I'd love to unpack a little bit further, which is this concept of AI agents. And as we've seen, the growth of both autonomous sort of IoT devices and these other intersections between, Web3 and kind of AI, this agent concept is becoming more mainstream and quite a bit more it's talked about quite a bit more. Can you talk about how you see the intersection of these AI agents, specifically leveraging LLMs, interfacing with Nosana, and maybe the broader kind of DePIN or Web3 market as part of the future of what you're building?
Yeah, definitely. Like that's the coolest part, I think, when there's a lot of cool DePIN projects out there also around AI, and I think when they all come, like agents is where they can kind of all come together and create like a wholesome decentralized Web3 AI experience, which I don't exactly know yet what it's gonna look like, but in the end, these AI agents will be able to because an agent should be self-operating, it should be sort of independent and being able to make decisions. And we're really getting there when you look at like these marketplaces where agents can find other agents and sort of interact with each other because they might be specialized and have different physical abilities or different capacities as digital agents. Obviously, Nosana can be used as a way to purchase your GPU power. So an agent can say, I need like some GPUs to do some fine tuning on this specific data set. So it can get a data set from a decentralized marketplace, and it can get like the GPU resources for the fine tuning session from Nosana, and then it can expose APIs and people can buy its services, and that can also be on chain. So I think there's a lot of different projects that are combined, creating the capacity for AI to become very independent and able to make decisions more independently. So it's a very cool future. I don't know exactly what it's going to look like, but the marketplaces, the compute, the data generation and data collection, And even things like human supervision, or like if there is a human input needed along the way, there are some really cool decentralized projects like Effect Network that are able to have a human in the loop. That's also basically on-chain, able to contribute in that process.
Yeah, no, I think that potential future is going to be something that's not only really, really big, but it does take the coordination of all these different components to be able to sort of come to fruition in a meaningful and sort of impactful way. And with that, are there other potential projects that are in the space, whether it's on the AI side or sort of in the DePIN side, that you see as being synergistic or potentially like a future partner opportunity within the Nosana ecosystem? Are there other things out there that are kind of tangential to what you're doing, but there's a lot of synergies that maybe finding yourselves as sort of a partnership opportunity in the future here?
I guess there's quite a few. Yeah, there's definitely quite a few. Like one of the beautiful things from the Web3 space is that there's so much collaborative spirit amongst projects, right? I think because we're compared to the Web2 space and the more larger companies and how they operate, we're just a very small group of people trying to make a big difference and a big impact and change the world. So I think we're all collaborating a lot. But for example, Render Network is a project that we're partnered with, as they have very different types of GPUs in their network than Nosana has. But the workloads that come in from either side might require some GPUs that are scarce on one of these networks. So getting a more fluid distribution of workloads across our networks is something that we're working on there. But then, like when it comes to more different AI-related projects, like I mentioned a few earlier, there is this Alpha Neuro, it's a decentralized Hugging Face type network that I think fits very well with our protocol, because decentralized AI models, they need a place to run in a decentralized way. So it's this beautiful, I think, way to stay decentralized even on the compute level, and on where customers look at an AI and I want this model and I want to run it now. To give them the option to purchase that compute power on Asana is just a very good connection. Those are two on the top of my mind. But there is so much cool stuff happening in the DePIN space. Like I love what Hivemapper is doing, like creating these digital, these open crowdsourced maps. There's too many to mention, but it's a good time for the DePIN space. I think there's so many cool stuff.
Yeah. Well, we've had the pleasure of chatting with tons of the really great projects in DePIN, and the amazing thing is that so many of them are needing to leverage LLMs or AI in various capacities. And so having a way to sort of bring that in at both a sort of an ethos aligned way, but in a way that actually drives costs down for these projects, I think is really amazing. And so it sounds like there's going to be so many different opportunities for Nosana to be able to bring that in at a better, sort of faster, stronger way that uses DePIN and really just makes the whole sort of supply chain there quite a bit better. I'm super excited about that prospects for both you and the space more generally. But what else is ahead for Nosana? You guys obviously have your hands full with building such an incredible protocol, but what else is sort of on the roadmap for folks to be excited about and looking forward to?
Yeah, it's very busy, definitely. Like we're keeping, there's a lot coming up. The next few months, we're mainly going to see use cases launch on the network. And I think for me, it's the most exciting part. So we're going to see these projects actually run workloads on our network. And then we're going to be talking a lot about it, like doing AMAs, writing use case blog posts, and sharing a lot of examples of how to run workloads on the network. So I'm very excited for it. We're going to also, I think, be able to make our network even more robust and fit all the use cases out there. But after that, we are planning on opening the deep demand side, so the grid for more and more people. So at the moment, we're mainly partnering with few companies that are have the technical team capable to work together with us and put these use cases out there. But pretty soon we will open it up for basically anyone that wants to participate to run their workload. So if you're an AI developer and you have a really cool use case, you want to get access to a ton of GPUs to run some really cool idea you have, then definitely get in touch with us. I think there's registrations open, or they're going to open soon, for running your own workloads on Nosana. that's pretty exciting. And then there's more cool stuff coming up. I don't think I'm allowed to talk about all of that yet, so I'm going to keep it at this. But it's going to be a very busy summer for us and a very exciting one.
Yeah, well, DePIN Summer is a real thing, and it's awesome that you guys are going to be busy building during all that time and bringing cool things to market. We're excited. Well, gosh, Jesse, we've talked about so many different things about what you're building, sort of the problem set, and really ensuring that you're creating a sort of a better world with using DePIN to take these LLMs to sort of the next level. But is there anything else that you wanted to add around just, the problem that you're tackling, or things we maybe didn't cover that are important for folks to know about before we get a chance to wrap it up?
Yeah, we covered a lot. I don't have anything specific, I think, that we missed. Just in general, I think I would like to share with people that LLMs are very cool and very accessible. So if you're like want to get into running some LLMs in like having your own custom version of ChatGPT, but running it not on OpenAI servers, which in the end are being powered by Microsoft, but having a bit more ownership of freedom of how you run your models, then definitely look into Hugging Face running, for example, Llama locally, and very soon you will be able to, with one click of the button, deploy your LLMs on Nosana's hardware, which gives you complete freedom of your personal AI assistant that you will have.
That's amazing. Well, where can people stay up to date with everything that you're working on, for those that are interested and ready to either become a contributor from the compute side, or they're on the AI side and they're looking for leveraging the network? Where can people stay up to date with everything that you're doing?
The best places are Twitter and Discord. So Twitter is Nosana AI. Everything is shared there. And the Discord is very active and busy, so you can find loads of information.
That's amazing. Very good. Well, we'll be sure to link all that information down below, the Twitter, the Discord. We'll link your personal as well. I'm sure you've got some nice, great takes that are coming out for folks to sort of stay up to date on. But Jesse, this is just a really interesting conversation. I love the fact that, not only is this AI thing so incredible, but so is the DePIN narrative for sort of enabling that to be a better version of what it is today. So I really wanted to thank you so much for coming on to share about what you're building. It is a very real problem, and you're using sort of novel ways to solve those problems in an equitable approach that sort of benefits everybody on the network. So really wanted to thank you so much for coming on and taking the chance to chat about that. For folks that are interested, be sure to go check Nosana out, go check out Jesse. We will link all of that below. But we'll wrap it up there. And so for any other questions, be sure to go follow them on their Twitter or drop them in their Discord. I'm sure they've got folks that are ready to answer those questions right away. And so we just want to say thank you so much again, and we'll see everybody on the next one. Take care.
Thanks. Bye.